Hello, I hope you're doing well. Just as promised, video 2 is going to go over the solutions to the practice problems that were assigned to you in the previous assignment, which was called vector additions and subtractions. These practice problems aren't very difficult, so I'm just going to go over them rather rapidly. So the first one was talking about a person moving 4 meters to the right and then 2 meters again to the right, and asked to go ahead and draw the resultant vector and state how many meters the person has walked. What is the total displacement of the person? The second question was similar. The person moved 8 meters to the right towards east, and then they walked 4 meters north, and it asked the same question. It said, what's the person's displacement? So I'm going to go ahead and show this to you. And I've checked a lot of people's work, and I gave them feedback from what we submitted. There were a couple of things I did suggest. I said, make sure you draw your arrowheads. It's very important when you add your vectors that you draw your arrowheads. And of course, adhere to the first rule of vector addition, that the two vectors must be touching head to tail. So this is the 4 meter vector's head touching the 2 meter vector's tail. And this is going to be a resultant vector because they're both pointing in the same direction. It's simple. It's just going to be 4 plus 2, 6 meters. The other one, when you rearrange the two vectors, it comes up to be a right triangle. So you have the 8 meter vector, and then the 4 meter vector is touching the 8 meter vector head to tail. Whenever you're rearranging vectors, just remember you cannot change their direction unless you have cause. If you had a subtraction problem, vector subtraction, then you could flip the direction. But otherwise, you cannot flip the direction. You cannot make a vector longer or shorter. By that I mean you cannot change its magnitude. And always remember to put the vectors head to tail and make sure to draw your arrowheads in your diagrams. So this is the 8 meter vector, the 4 meter vector. The displacement is going to be the hypotenuse. So the resultant vector is the hypotenuse, and you notice I draw the arrowhead in there, and I've used Pythagorean theorem to solve for the hypotenuse. A squared plus b squared equals c squared, so c is going to equal the square root of a squared plus b squared, and that right there is the solution. 8.9 meters, and I've drawn the direction for you. Later on, we'll talk about determining the angle theta that exists between the resultant vector and the x-axis. So we'll talk about that as we continue discussing vector addition and the components of a vector. I hope this was useful, and hope you review this and make some edits to your own work. Please take a look at the comments I gave you in Canvas when I graded your work, and if you have any questions, feel free to ask me during our office hours this coming week, Monday and Wednesday online, as well as our breakout, which will be on Thursday. Thank you.